Imagine a world where doctors could figure out everything that's wrong with your body before it ever affects your health. Right now, our healthcare system is a little bit different than that. It's based on reactionary medicines and procedures to get you healthy after you've come to the doctors with a complaint. But our body possesses a blueprint inside of it. And this blueprint is the key to all of our health issues. It's the key to figuring out what we're susceptible to, what our body will have issues with. And this is the human genome. And doctors have been able to detect susceptibility and reactions in certain genes that make up who we are. And these reactions in these genes can determine if we develop cancer. Will we develop some type of blood issue? All these things can be discovered through research in genes. It's basically like a car. When you take a car to get a service, they plug a computer into it and they figure out every issue that the car has with the car's codes that it's throwing to the computer. A mechanic can then figure out all these issues and prevent catastrophic failure in that vehicle. That same idea will now be taken into healthcare that is taken with our vehicles. We will be preventing major incidents from happening instead of trying to react always to the things that happen in our body and the things that flare up that we can see formulating in the human genome. Genomic analysis through long-read sequencing, short-read sequencing, and optical genome mapping is revolutionizing the way society will manage their health by changing the healthcare system from a primarily reactive state to now a preventative healthcare state, to where we're now reaching out and trying to prevent things from happening before they turn into cancer, before they turn into major health issues. And getting your body's genomic makeup analyzed gives you the freedom in understanding exactly what is going to happen in your body. And it gives you the ability to take preventative action to ensure that your body won't experience these pains later down the road. If you figure out that you're susceptible to getting heart disease, you'll avoid certain foods. If you figured out your lungs are susceptible to getting dull and filling with phlegm, you'll take the proper vitamins you'll need in order to stay healthy. Understanding the 3 different types of genome testing that are primarily used today will allow you to understand why all 3 of these together can be extremely powerful in the new healthcare world. Then I'll explain how gene receptor activity gives doctors specific answers to diagnosis. Finally, we'll get into just the overall learnings in this and how the technology and the things that are coming out will not only create a world without disease, but hopefully without any virus or any developmental issues in people anymore. And then the 3 leading types of technologies today are the short read sequencer, the long read sequencer, and the optical genome mapper. All right? The short read sequencer, or SRS, was created by Illumina. And they hoped it would create the $1,000 genome, that everyone would be able to get to analyze their genomes for $1,000 and figure out everything that was wrong. And this was according to the AFR JLab that posted that article from back in 2014 when the groundbreaking technology broke. This technology began to show its flaws in its inability to sequence long stretches of DNA as they appeared on the body. This is according to Martis E., who wrote the 2006 to 2016 DNA Sequencers Technology book, which disclosed all the information that was learned in that 10-year period about DNA sequencers, and is the best for looking deep into the human genome. We're going to be looking at the human genome like a book today. So in that book, when you open that book and you go to a specific letter, specific word, not to the letter, but we can now look at the whole letter and every letter in that word with the short read sequencer. Now the long read sequencer, it's going to be created by Pacific Biosciences in 2018. It's using a larger processing core than the initial Illumina machine and combine the fragmented layers of gene computed by the software in order to build a much larger analyzation of the gene, hence leading to more understanding of the connections and the rest of the genomic analyzation sector. So this is basically be like, if you're opening that book again, now you're looking at the sentences. All right, so now we're getting to the optical genome map, which was created by Bionano Genomics in order to see the entire genome. And therefore, by seeing the entire genome, you could see multiple large issues rather than just going so deeply into the book. If you're looking for a misspelled word, would you have to search the whole book and maybe like to see the whole page? Or would you like to go just at one word each time? Just pecking. No, with the optical genome mapper, you can see all of it. So you're seeing each page now. So now you can see each page, and now you can see each sentence, and now you can see each word. So now we're getting into the specifics of understanding the entire human genome. And these factors can be seen in the analysis that comes from the human genome and being a much flatter form so you can understand the entire thing and how it's built. All life-changing existences in the body change through the genome. Nothing goes on in the human body without first happening in the human genome. And in order to understand this, you have to understand all the actions of the genome. For example, prescription drugs have an effect because we understand how our body reacts to them in our genome. And Illumina has shown that with their studies through NGS for drug development, that they can test for issues in specific drugs and reactions they will have on people that was not understood before. So when you see a laundry list of side effects for a drug that you see on some commercial, i.e. depression, drowsiness, lack of mood, lack of just motivation, all these things can be discovered through the reactions that they cause in the human genome. Pacific Biosciences currently working with their long-read sequencer on the reactions that could be causing the blood clots with the Johnson & Johnson vaccine recently produced. Because this COVID-19 vaccine was causing all these blood clots in people, now they're going in with a long-read sequencer because they understand what the issue is, so they can go after it specifically. So now, the doctors have been able to identify new things with optical genome mapping. And through the neural development process, you can understand through the combination of three specific genes, why autism and autism spectrum related disorders exist. Through the manipulation of understanding these three genes, structural variants. And this is from the Global Newswire. Another recent discovery made by Bionanogenomics was that in 37 severely ill COVID-19 patients, all 37 had hyperregulation of STK gene 26. This gene, when hyperregulated, produces a hyperimmune response. This is the answer to the question why some people would get sick and other people would get the virus and be completely asymptomatic. As biotechnology and all these things can come about, genomic analysis will be a major proponent of diagnostics moving forward. Medicine is breaking into the new age of understanding, and we will become to see how short-read sequencing, long-read sequencing, and optical genome mapping will create a new healthcare sector that will be far better than everything we know today, because we'll be preventing things before they happen.